Welcome to Pre-Calculus. Today we will calculate interest rate or time in compounded investment. We'll take a look at two examples, one in which we find the interest rate, one in which we find the time. First example involves the situation with Dan investing $3,037 in a retirement account with a fixed annual interest rate of 3.40% compounded monthly. We're trying to find out how long will it take for the account balance to reach $5,988.91. So since we are looking at something that is compounded, in this case, monthly, that tells me that the formula that I need to pick up is the one that involves compounding in certain intervals over the year. So remember, that one's going to be A, the future value, equals the principal, times this base that we represent as 1 plus the interest rate divided by the number of times that I compound the interest in the year to the power of that same n value times time in years. So let's fill in our equation with the information that we have, keeping in mind that what we're looking for ultimately is the time. So I do need to fill in for the principal, the future value, the interest rate, and the n value. How many times is the interest compounded each year? So we'll fill in with these values. So the future amount is this $5,988.91. That's my A value. I'll make the substitution. The principal is going to be the smaller amount, since this is a growth situation. So I'm going to put for principal 3,037. I know it's 1 plus the interest rate. So if my interest rate's given as a percentage, 3.40%, that's equivalent to 0.034. I could put that last zero, but we really don't need it. Remember, you just move that decimal twice to the left. I need to decide about the number of times that I'm investing the amount each year. So I always look for the word after the compounded. In this case, it's monthly. So if I think about how many times, or in this case, how many months are in a year, that gives me an n value of 12. There are 12 months in the year. Note that that is repeated in the formula. It's both in the denominator under the rate. It's also in the power by time. So that's set up. I do want to highlight again what we're trying to solve for. It's that time value. So again, what I need to do is I need to reduce this all down and get time solved by itself. So it is in the power, which means I'm going to have to use a logarithm. But before I do so, I need to recall that this base to the power needs to be isolated first before I can apply the logarithm. So I'm going to start by dividing by the coefficient 3,037. That'll cancel there on the right side, and we'll record it here on the left. Similar to like what we did with continuously compounded interest, I don't want to do any intermediate calculations. I don't want to make any rounding. So I'm going to just record the entire expression, and then I'll input that into the calculator at the end in its entirety. So I'm not calculating there. I'm just putting the fraction 5988.91 over 3,037. And then on this right side, base 1 plus 0.034 over 12 to the power of 12t. So I do want, at this point, since that base to the power on the right is isolated, I can apply the logarithm. In truth, I can apply any base logarithm. So since this one doesn't involve e, I'm just going to use log base 10. And remember, we don't have to write the base. A lot of times that's suppressed on log base 10 since it's the default logarithm. So the entire goal of that, remember, was to get 12t as a power to descend as a coefficient. And that, using our power property of logarithms, will definitely take place right at that moment. So now what we've got is log base 10 of that fraction of the future value over the principal. And that's going to equal now 12 times time times the logarithm base 10 of 1 plus the interest rate over the n value. So at this point, everything on the right side is on the same level. So what I need to do is divide everything that's not time. So I'm going to divide by 12 to cancel the 12. I'm also going to divide by log base 10 of 1 plus the interest rate over the n value. And with those two divisions, all that's left on that side is time. So ultimately what I'm going to input in the calculator is this left side. So it's going to be divided by the same 12 log base 10 of 1 plus interest rate 0.034 over 12. And that's ready for me to input into the calculator. So I'm just going to record it. And as you can see, again, we did not do any intermediate calculations. We wait till the very end to calculate the entire expression. And that way we don't have any error due to rounding. So let's head to our calculator to find that time. How many years will it take? So I have a fraction. I've got log base 10, and then I've got a fraction within the numerator. So it's 5988.91. That's the future value over the initial investment, $3,037, over 12 times logarithm of another sum, 1 plus, and then a final fraction, 0.034 over 12. And notice that's giving us a very close number to 20, 20.000022, so forth. And in fact, we'll round that to 20 years. So after all of our calculations here, we get down to simply time equals 20 years. Well, that was an example that involved us using a logarithm to find a time. Let's take a look at an example that involves finding the interest rate. So in this example, we are thinking about Carlos investing $2,397 in a savings account with a fixed annual interest rate compounded every 2 months. Notice we aren't told the interest rate. After 5 years, the balance reaches $2,689.88. We're interested in what's the interest rate of the account. So as I notice here, I just need to pick up again my formula. It's going to be the same one we just used because I see this classic compounding every certain interval in the year. Again, that tells me to pick up this formula. A, the future value equals the principal times the base 1 plus the rate over the n value to the power of n times time. The thing that we are going to solve in this case is the rate. So ultimately, that's what we're trying to solve for. Everything else we're going to input values for. So let's do that right away. Let's input for the A, the future amount. So that's the larger of the $2 amounts. So that's $2,689.88. That's going to equal the initial investment, the smaller value, $2,397. times 1 plus the rate. I need to decide about the n value. It is given here in the phrase every 2 months. So if I think about how many times that would occur in a year, there's 12 months in the year. So if I'm compounding the interest every 2 months, I would compound that interest 6 times in the year. So my n value is 6 to the power of 6. Again, you repeat the n value in the exponent times the time. I'm looking for a year amount, and that's given here as 5 years. So that's the setup. Just to emphasize, I'm looking for the interest rate. So let's approach this one. I want to get that interest rate solved for. So what I'm going to do first is divide by this 2,397. A lot of times you want to get rid of that coefficient. So the division will cancel it on the right, and it'll show up under the future value on the left. So now what we got is $2,689.88, the future larger value over the principal 2,397, equals just now the base 1 plus the rate over 6 to the power of 30. And at this point, I want to get rid of the power of 30. And so what I'm going to do is apply the inverse operation to the power of 30, which is the 30th root. So we'll put the radical, and we're taking the 30th power. And on the right here, that's going to cancel. And now what I've got on the left side is simply the 30th root of this quotient, $2,689.88 over $2,397. And now this base is isolated. It's now simply 1 plus the rate over 6. So I've got just 2 steps left. I want to now subtract 1. And let's bump this over to another column here on the right. So currently I've got the 30th root of this fraction, 2,689.88 over 2,397. The minus 1 is going to be on the outside of that radical. And that equals the R value, the rate over 6. So to solve here, the last thing I need to cancel on the right is that 6. I'll do so by multiplying by 6. And I'm going to multiply that entire left side. So again, I've solved for R. I've built up the left side. So I just need to record it and input that entire left expression into the calculator. So we'll head over to Desmos to make that calculation. So we had a 6 on the outside, brackets, and then I need to locate the 30th root. It's not a common root, so what I'm looking for is here under the miscellaneous tab, the nth root. That'll allow me to type in the index 30. Under the radical, again, I got a fraction, $2,689.88 over $2,397. And then on the outside of the radical, minus 1. And that's given me this decimal value of 0.0231000 and so forth. So what I'll do is I'll record 0.0231, and let's finalize that as a percentage. but we'll head back to our notes screen. So on the notes here, we end up with the solution R rate equals that decimal 0.0231. So again, that's a decimal. If I wanted to convert it back to a percentage rate, I would move that decimal 2 to the right, 2.31%. And that indicates why this is such a low growth. It's not a whole lot of growth from about $400 to a little less than $700 after 5 years. And the reason for that is it's a small interest rate, 2.31%. So thanks for joining for these two examples, one where we had to use a logarithm, one where we had to employ the 30th root. So again, thank you for joining for investigation of finding time or interest rate in compounded interest. See you soon.